In this video, I'll give an overview about our paper with the title A Phase Field Framework for Capillary-Induced Fracture in Unsaturated Porous Media, Drying-induced versus Hydraulic Cracking. The work on this paper was carried out at Columbia University in New York in the group of Professor Wai-Ching Sun. And the highlights of the papers are as follows. So we had a phase field fracture model, which is embedded in unsaturated three-phase continuum porous material. We applied simulation of drying or wetting-induced fractures in a unified model. And we had microstructure-based interpretation of the stiffness degradation. We captured also the changes of the permeability or onset of anisotropic permeability and the changes in the volume fractions due to the onset of cracks. And we had at the end qualitative comparisons between the numerical model and also experimental data. So after the introduction, we had in section 2 the detailed description of the continuum unsaturated porous media model, including the homogenization and the definition of the volume fractions. Then we had in the third section the description of the phase field fracture model, including the diffusive interface, and also the two scenarios for the fracture, namely the drying-induced and the wetting-induced. Then we had in section 4 a summary of our governing equation. And in section 5, we talked about the numerical treatment of the set of strongly coupled equations. In this, we applied like a combined staggered monolithic approach. And in section 6, we had two numerical examples. One of them, as you see here, it's the drying or desiccation-induced fractures, where we have out-of-flux at the boundaries and the evolution of cracks, which is also depending on the chosen material parameters. So if you are interested in this paper, please check the description of this video for links. And if you have any questions or whatever, you can simply contact me. And thank you so much.